Alright folks, I'm going to show you how to solve an NCEA-style question on complex circuits. So any NCEA-style question that you encounter on the exam or the mocks or whatever is going to be a multi-part question, and each part gets you an achieved merit or excellence point. So first thing that you will need to do is read the whole question. I've broken it up into chunks, so we'll go through them a chunk at a time. First chunk is, use the following circuit diagram to answer the questions below. A, show that the total resistance of a circuit is approximately 10 ohms. So, first thing we want to do is notice that this is a show that question. Show that questions mean that it tells you what the answer is. The total resistance is approximately 10 ohms. But we need to prove it, which means we need to show all our work. Show your work. Show your work. Show your work. So, first thing we're going to do is we are going to look at our hold on. We're going to look at our circuit diagram right here, and we want to start right here at this parallel bit right there. We want to work out the total resistance for that chunk. So that is 1 over the resistance of 2 and 3 together is 1 over the resistance of 2 plus 1 over the resistance of 3, which in this case is 1 over 4.80 plus 1 over 7, which gives us a total resistance for this chunk right here of 2.8474, etc. Are we done yet? No, we're not, because we have to find out the total resistance of the whole circuit. So, how do you find out the total resistance of a circuit now in series? This guy is in series with that one. You just add them together. Total resistance of bulb 1, resistor 1, plus total resistance of 2 plus 3 that we worked out up here. Plug in our numbers. R sub t total equals 7 plus 2.84, etc. We get a total resistance of 9.847457627, and we want to take that to three significant figures, excuse me. So that to 3 significant figures would be 9.84, which is approximately 10. Rounds to 10, pretty close to 10. And if you get that, that is your achieved point. But you must show all the work. If you just tell me R sub t equals 9.84 without showing how you got there, that is not worth any points, even though that is the correct number. Okay, next section. Calculate the voltages across bulb 1 and bulb 2. So bulb 1 up here, bulb 2 over here. So first thing we want to do is break it up. We want to do bulb 1 first. So for bulb 1, we're going to be using V equals IR for all of these. And what do we know and what do we need to know? We do not know the voltage of bulb 1. That's what we're trying to figure out. Do we know the resistance? Yes, we do. It's 7 ohms. We're told the resistance right here. Do we know the current of bulb 1? Not right now, we don't, but we can work it out. So in order to work out the total, or the resistance for a component in series, you need to work out the current total, because the total current is constant for resistors in series. So we're going to start by working out the total current for this whole circuit. You do that by knowing the total voltage, which we do, it's up here, and the total resistance, which we worked out in the last question, 9.84, etc. Throw that into V equals IR, rearrange it, we get total current equals V over T divided by, V sub T divided by R sub T, total voltage divided by total resistance. Total voltage is 12, total resistance is 9.84 from the previous thing, which gives us a total current of 1.218, etc. So the total current for the whole thing is 1.218. The rule for currents in series, according to our table on 285, is that currents in series are constant. So the current for the whole thing is equal to the current for bulb 1 is equal to the current shared by bulb 2 and bulb 3. So the current for bulb 1 is going to be the same as the total current for the whole circuit, which is going to be 1.218, etc. Are we done? Of course not. We need to then plug that into our V equals IR equation. We still know the resistance of the bulb 1 component. We now know the current of the bulb 1 component. plug that into V equals IR. It should look like that. Current of bulb 1, resistance of bulb 1, multiply those together, we get voltage of bulb 1 equals 8.530120482 volts. We want to take that to 3 significant figures. It is 8.53 volts. Must have the rounding, must have the unit in order to have it correct. If you forget either of those, you lose credit for the question. Are we done with the question? No, we're not. We still have to calculate bulb 2. Bulb 2. We once again start with V equals IR, and once again start writing down what we know and what we don't know. We don't know the voltage for bulb 2. That's what we're trying to work out. We don't know the current for bulb 2. But we can work it out because we know the total current. We know the current is going to be shared across bulb 2 and bulb 3. We also know the resistance for bulb 2. So the first thing that I would do is I would work out, I would start by noticing that if bulb 1 has a voltage of 8.53 volts, the only voltage available for bulb 2 and bulb 3 is going to be whatever remains out of 12. Because the total voltage for the whole for the whole circuit is 12 volts, and bulb 1 is using 8.53 volts of that, so bulb 2 and bulb 3, whatever they've got going on, has got to be using only what's left, which is 3.46, etc. And in fact, for components in series, voltage is shared between them, so bulb 1 is sharing that with bulb 2 and bulb 3. For components in parallel, bulb 2 and bulb 3 are in parallel with each other, their voltage is the same. So bulb 2, bulb 3 both have the same voltage, which is this 12 volts minus 8.53 volts equals 3.467 volts. Round that to 3 significant figures, we get 3.47 volts. And you can check that by adding that and that together. Does it equal 12? Yes, it does, because that's how we got it in the first place. This question will get you an achieved point if you get the current correct or either bulb voltage correct. So the current up here or either bulb voltage correct. Get a merit point if you get both voltages correct, this one and that one. Alright, section 3. Bulbs 2 and 3 are not the same brightness. Discuss which bulb is brighter and why. Discuss. That means that we do not have to do any calculations for this question. You can, and you can include them in your discussion, but you must also explain. So, they're asking about bulbs 2 and 3 being not the same brightness. The thing that tells us how bright a light bulb is the power that it uses. And power depends on voltage and current. So there's a couple of ways to describe this. You can say that the voltage across both bulbs is the same. We just discussed that in the previous question. However, they don't use the same current. Bulb 2 is going to use more current than bulb 1 because it has a lower resistance. Because I equals V over R. If resistance goes down, voltage remains the same. That means that current is going to increase. If they've got the same voltage and this one has more current, that means it is going to be brighter. And here's a way to describe that. Voltage across each bulb is the same, however the current through bulb 2 is higher due to having a lower resistance. I equals V over R. Bulb 2 uses more power, and you can calculate the wattages but do not need to, and is therefore brighter from P equals IV. Or you can use the power equals V squared over R equation. The same voltage but different resistances will mean different power consumptions. Not bean, sorry, that's a typo. Resistance remains the same, but two typos in there. If the voltage, that should read, remains the same, but resistance decreases, power will increase, therefore bulb 2 is brighter as it has a low resistance. These descriptions are pretty much the same as each other. However, this one describes it in terms of I equals V over R. This one describes it in terms of V squared over R. You'll need to refer to an equation in any sort of description or discussion of how to work this out. But again, you do not need to solve any equations, but can and use that in your discussion. So in order to get the achieved point on this one, you must state that bulb 2 is brighter, or you can state that bulb 2 has more current, and that power equals brightness, or anything else that is correct from this here. So just basically one correct thing and the rest of it's wrong. For merit, you got to say two correct things, so the voltage across each bulb is the same would be a statement, and stating that the current through bulb 2 is higher would be another correct statement. And you need to link them together. And merit, you need to basically have the whole description, this one here, or that one there, referring to an equation. That'll get you up to excellence. Okay, so the last bit right here, we want to discuss the effect adding an ammeter has on current, voltage, and brightness of each bulb. So we've added an ammeter right here in the current, or in the circuit. So an ammeter has negligible resistance, which means very little, effectively none. We've added it here. So what is all the electrical current going through this section going to do? It's all going to pass through the ammeter, and none of it's going to pass through bulb 1. So bulb 1 is actually going to go out because it's basically being short-circuited. Therefore, there is more current left, or sorry, more voltage left for bulb 2 and bulb 3, and their resistances remain the same. Therefore, their current will have gone up. The total current traveling through the whole circuit will have gone up, and the total current traveling through each of these sections will have gone up. The total current will have gone up because the total resistance will have gone down, because we no longer have the resistance of this component right here. That looks something like this. Adding the ammeter short circuits bulb 1, all the current goes through the ammeter and none through bulb 1, thus with your 0 volts and 0 watts of power for bulb 1. This causes the total resistance of the circuit to drop from 9.85, which we calculated before, to 2.85, basically the same thing minus the 7 ohms here. Increasing the total current, calculate right there, from 4 to 4.2 amps from 1.2 amps. Voltage across bulbs 2 and 3 is now higher, 12 volts, increased from 3.74 volts. Since the current is higher and the voltage is higher, the brightness will increase. Bulbs 2 and 3 get brighter. Achieved if you say that bulb 1 goes out or that bulbs 2 and 3 get brighter without much explanation. That'll get you your achieved. Merit, bulb 1 goes out because there's no current through bulb 1, and also bulbs 2 and 3 get brighter. That'll get you your merit point. For excellence, you have to have as merit and also explain brightness in terms of current or voltage. So you have to include this bit down here for the excellence point on that one. There you go. The important things are to read the question and answer the question that is being asked. I have lost count of the amount of times that people have told me correct things that are not actually an answer to the question being asked. So make sure you are actually answering the question that is being asked. Cool. Thank you very much, and let me know if you guys have any questions.